Here's integrated 3. It's your 10.3.1 lecture part 2. We've done problem 10-137. We're going to skip 10-138 and we're going to do 10-139. 10-139 says Cheryl is playing a game with her brother. They toss 4 coins and Cheryl wins every time an equal number of heads and tails appear. Is this a fair game? Make a conjecture. So this is kind of exactly like the ice cream situation in the last problem, where if she got exactly 2 hits, then her dad would give her ice cream. So I don't really want to draw a brand new heads and tails model because I could just kind of use this one. The only difference between this model for the hits and misses in the problem 10-137, the only difference between this and heads and tails would be these would both be 50. Instead of one being 40 and one being 60, they'd both be 50. But there's 4 coins, so we could still use this to look at 4 coins. That would be 1 toss, 2 toss, 3 tosses, 4 tosses, but just the numbers would be a little bit different because they'd all be 0.5, because when you flip a coin, it always has a 50-50 chance, heads or tails. So there would still be, so let's see if we can use that to answer the question. Is it a fair game? Oh, well, we already know from this one, we already know that, wasn't it like a 35% chance? So that's not fair. That's not a fair game. And you can actually look at it, or I think it was you can look at it, like, if you just skip to the next problem, it shows all the heads and tails if you threw 4 coins. And to get exactly an equal number of heads and tails, there's only 6 out of 16 I don't know, trials, I guess you could say. There's only 6 out of 16. That's about 38%. So just to answer the question, all they're asking is it a fair game? We're going to say no. It's not a fair game. What's the probability that Cheryl wins? Well, I can get that 38 just by looking. I mean, you notice I was too lazy to draw this all the way out because it would take a long time to draw. Not that long, but it takes kind of a long time to draw this out. So there's a quicker way to find out the 38% if you don't already have this. And so that's what I want to show you. Because here you can just go 6 divided by 16, because there's 6 out of 16, the probability is 38%. But let's try it this way. The combination of 4 things taken 2 at a time times the 1, 2, 3, 4, 50 to the 4th power. So how do I get the combination of 4 things taken 2 at a time? Why is it 4 things? Because there's 4 tosses, there's 4 coins, and we're looking for exactly 2 successes. So if you remember this from the math notes box, factorial means you take the number. So in this case, n is number. You take the number and you multiply, I call it downhill, in descending order by integers. Like you go 4 times 3 times 2 until you run out, until you get to the 1. And then r, well, that's 2 here. So that would be 2, it's r factorial, 2 times 1. And then n minus r, that would be 4 minus 2. So that's another 2 factorial. Okay, so some stuff will cancel out. That canceled out. That canceled out. The 1 doesn't really do anything. 2 cancel. So this is 6. So they're telling me that 6 times 0.5 times 0.5 times 0.5 times 0.5 is going to give me my probability there. So I'm just going to go 0.5 to the 4th power. And then I'm going to multiply it by 6. And that gives me my same 38%. Sorry, that's work from a different problem. Which is the exact same thing I got right here. But sometimes, since I was, mentioning that it takes a long time to draw a big tree diagram, you can just use this combinations to find out how many, like if I wouldn't have had this here, I wouldn't have known how many of the trials would have just exactly 2 heads or 2 tails, or, like exactly, what does she say? Exactly half, or an equal number of heads and tails, which means exactly 2 heads or exactly 2 tails. So I just want to bring your attention to this, how you're using these combinations. I think we'll just try to do 10-140 just to make sure you can figure out how to use the combinations. So on, my dog's crying. 10-140 says Cheryl's brother does not understand why Cheryl says the game is not fair. So she shows them by making the table. And then, are each of the outcomes equally likely? How do you know? Well, each one of these, they are equally likely. That's different than the one where the girl had the batting average of 40. She was getting hits 40% of the time and misses 60. On coin tossing, it's always equal. So it's always going to be 0.5 times 0.5 times 0.5 times 0.5. On letter B, it says, use the table to explain why this is not a fair game. Well, you can look at the table, and yeah, I like that. I mean, I did the math right here, but you can just look at the table and see that there's only 6 out of 16 ways. So less than half of the results have equal number of heads and tails. So that's not a fair game. And then on letter C, Cheryl decides to rewrite her table using a shortcut. So you might see this sometimes in your homework problems, this little shortcut. When she has 3 heads and 1 tail as an outcome, no matter what order, she writes it as 3 or H3T1. Okay, so there's just another way to write that. See, that's 0 heads and 4 tails. And then on letter D, it says, Cheryl's brother suggests that the game would be more in Cheryl's favor if Cheryl only has to get 2 heads out of 5 coins. So what is the probability Cheryl will get exactly 2 heads in this new game? Which game would Cheryl prefer? So I don't want to draw this. Sorry. I don't want to draw one of these for 5. I mean, I guess if you already have one drawn, you can just extend it out. But I know, and your book tells us, that we can use combinations instead. So let me get a new piece of paper here. Let's use combinations to find out what's going on here. So I do know that there's the formula for combinations that you might not have it memorized. So the combination of n things taken r at a time is n factorial over r factorial times n minus r factorial. So we'll keep that, and then let's see if we can figure this one out. So now there's going to be the coin tossing. There's going to be 5. It's going to get tossed 5 times. So I want to know how many times she's going to get 2 heads out of 5 coins. So that's the combination. There's 5 coins, and we want 2 heads. So this is n, and this one's r. So it's 5 factorial over r factorial, that's 2. And if you don't mind, well, I'll write the 1 on there, but just know that the 1's just going to cancel out. And then n minus r, that's 5 minus 2, so that's going to be 3 factorial. And I don't want to get out my calculator and find out what 5 times 4 times 3 times 2 times 1 is, or maybe you can do it in your head. I'm just going to do fraction math because I prefer fraction math, so I'm going to cancel these out. And I'm even going to cancel the 2 and the 4 out, and I'm going to get 5 times 2 is 10. So all I have to do is take my 10. That means 10 of the trials is going to have exactly 2 heads. So then I just have to find out what's the probability, though. It's like there's 5 coins. 1, 2, 3, 4, 5. So it's going to be 10 times 5 times 5 times. Well, I'm just going to use my calculator and find out what 5 to the 1, 2, 3, 4, fifth power is. So, or 0.5. 0.5 to the fifth is that. And then I'm going to multiply it by 10 because I know there's 10 of the trials have exactly 2. So that's about 31.25%. So that I don't think that made it equal. So Cheryl's more likely to get, so remember in the last one when she was using 4 coins, she was likely, I think it was 38% chance that she would get 2 heads. So this actually doesn't help at all. So letter E says, for the game in which 5 coins are tossed, instead Cheryl suggests she will be the winner if so if she gets 3 heads, 2 tails, 4 heads, 1 tail, or 5 heads, 0 tails. So what's the probability that she wins? Is it a fair game now? So I'm going to leave this to you. Basically, you're going to have to add, you're going to have to get results for this one, and this one. So this one you're going to have, there's always 5 things. But this one will be, there's 3 heads, so 5 things taken 3 at a time. Sorry, 5 things, taken 3 at a time because 3 heads. 5 things taken 4 at a time. And 5 things taken 5 at a time. And you multiply each of those by, the 1, 2, 3, 4, 5 coins. And you add them all up, and it ends up being very close to 50%. I'm going to let you guys try that on your own because I'm running out of time in my video. And then you can just email me with any questions that you have.